So I just got my hands on this question paper, and no violence intended, but I just thought, I could go over it, just quickly go over the questions, giving answers to the best of my abilities, just for those people who would like to see how did they perform. So in this video, I will only be going through the multiple choice questions. Okay, so question 1 here says, which one of the following combinations consists of only scalar quantities? A says velocity, which makes it incorrect immediately because velocity is a vector quantity. And then in B, we have time, distance, and speed. Indeed, these are all scalar quantities because they do not have magnitude.
A man and his daughter were walking in the forest.
Because they do not have. And we can even check C here. C includes acceleration immediately. That's incorrect. This is displacement, velocity, and acceleration. And all of those are vector quantities. So the answer for 1.1 is B. And then 1.2, the acceleration due to gravity on Earth is g. Which one of the following represents the acceleration due to gravity on a planet that has twice the mass and half the radius of the Earth? Okay, so for this one, we can apply Newton's second law. F net is equal to ma, and so we want the acceleration. Acceleration is F net divided by the mass. And then now, based on Newton's universal law of gravitational what's that law called again? Newton's universal law of gravitation. We know that the force is given by the constant g multiplied by mass of one object and the mass of the second object divided by the square of the distance between their centers. So in place of F net, we can just write that, but you need to take note that one of these masses here, since we are considering the interaction between this planet they are telling us about, right? As well as any object that is on the surface of that planet. So this planet, let's give it a capital letter M instead. So instead of M1, for example, here, let's write capital letter M. And then for the object on the surface of the planet, we will say it has a mass of small letter m. So we'll just leave that as small letter m. So this is the expression for F net. And then we need to divide it by m. So you should not forget this m here, right? Which is just from Newton's second law. And this is because we want to know the acceleration of an object that is on the surface of this planet. And that object is what we have given a mass of small letter m. And now on what we have here, you can see that m will cancel this m. And then what we get is that the acceleration is actually the constant g multiplied by the mass of that planet. So acceleration, this is a, divided by the square of the distance between their centers. So from the center of the planet to the center of the object that is on the surface. Now, on Earth, we know that this acceleration is equal to G, right? So this is equal to G on Earth. But now, what about on a planet that has twice the mass and half the radius of Earth? So for that planet, you would have A is equal to G. And then we have been told that the mass of this planet is 2 times the mass of the planet Earth, because it's twice. And we are also told that this planet has half the radius of the Earth. So we have 1/2 radius to the power of 2. This will simplify to, we can take these 2 out and then write G and M. And then this here, 1/2 squared, will be 1 divided by 4 r squared. And now 2 divided by 1/4 is equal to 8. So we have 8 gm all divided by r squared. And remember that we did show that gm over r squared is equal to the small letter g. So this gm r squared here, we can write g in place of it. So the acceleration on this planet is 8g. So the answer for 1.2 is D. Okay, moving on to the next one. Now 1.3 says a ball is projected vertically upwards from the ground and it reaches its maximum height after a while. Ignore the effects of air friction. Now the question is, how will the acceleration and total mechanical energy of the ball at its maximum height, okay, so at its maximum height, compare to that immediately after it was projected? Okay, so we are being asked here to compare. Okay, so they are asking us whether how does the acceleration, the total mechanical energy of the ball at the maximum height compared to that immediately after it was projected. So let's say the ball was projected from here, and then after a while it will reach its maximum height there. So if that's the maximum height there, what will be the acceleration there compared to the acceleration immediately after it was projected? For the acceleration, it's simple because it is projected and we ignore the effects of air friction. So this is a projectile that is undergoing a free fall. And we know from the definition of a free fall that acceleration is due to gravity, so it's equal to 9.8. It doesn't matter at which point the projectile is. So for acceleration, it will be equal to, because the acceleration is constant throughout the motion of a projectile. And now for the total mechanical energy, we ignore the effects of air friction here. So it means that from the point where the ball was projected to the point where it reaches its maximum height, this is an isolated system because we ignore the effects of air friction, meaning that the total mechanical energy, the maximum height, will be equal to the total mechanical energy immediately after the ball was projected. So it means that the correct answer for 1.3 is A. Okay, now 1.4 says a car travels at constant velocity along a horizontal road. Okay, this is very important. So a constant frictional force acts on the car during its motion. And the question is, which one of the following statements about the power dissipated by the engine of the car during the motion is correct? First thing here that they have told us is that the car travels at constant velocity, which means that the acceleration of the car is 0 meters per second squared, if you like. And if acceleration is 0, it also means that the net force is also equal to 0. Remember that these are directly proportional to each other. Okay, so you must remember that power is the rate at which work is done. Okay, and work is the force multiplied by the displacement cosine of theta. So we divided that by the change in time. But if the force or the net force applied is equal to 0, it means that the power will be 0. All of this will be equal to 0. So the answer is A for this question. And now for 1.5, they say block X is placed on a horizontal table and is connected to block Y by a light inextensible string passing over a frictionless pulley as shown below. A constant frictional force acts on block X. So there's a constant frictional force acting on block X while it moves to the right. And now they say P, Q, and R are points on the table such that the distance from P to Q is equal to that from Q to R. Okay. And now they go on to say that when block X reaches point Q, this point here, the string is cut and block X continues to move towards point R. Ignore the effects of air friction. And now they say consider the following statements. And the first statement says the work done by the frictional force acting on block X is greater when the block moves from point P to Q than when the block moves from point Q to R. Well, that does not make sense. This really does not make sense because we were told that this frictional force is constant. Remember that work is given by the product of the force and the displacement cosine of theta. So if this is constant, right? So because we are considering the frictional force, so the frictional force is constant. In addition to that, we were told that the distance from P to Q is equal to the distance from Q to R. So it means that this work, when the block is moving from P to Q, should be exactly equal to the work that the friction does when the ball moves from Q to R, because these distances are equal and the frictional force that the block will be experiencing is constant throughout. So this is an incorrect statement. And now the second statement says that both the momentum and the kinetic energy of block X decrease when the block moves from point Q to R. So from point Q to point R, right? So it says that the momentum and kinetic energy decreases. Well, we know that the momentum and kinetic energy are directly proportional to the speed or velocity of an object. Okay, and we're told that at point Q, when the box reaches point Q, the string here was cut. So it means that the block will be no longer experiencing this tension force that is pulling it to the right. And the only force that will be acting on the block will be the frictional force, which is opposing its motion. So that alone tells us that from Q to R, the speed or velocity of the block will be decreasing. Okay, so when the ball reaches point R here, it will have a smaller speed compared to when it was at point Q. And since momentum is equal to mv and kinetic energy is equal to half mv squared, yes, it's correct. They are both going to decrease. And now the third statement says the total mechanical energy of block X remains constant when the block moves from point Q to point R. This is very incorrect because, first of all, this is not an isolated system. There is friction that is acting, and energy can only be conserved if the system is isolated. And friction is a non-conservative force, so this is an incorrect statement. So they say which of the following above is or are correct as block X moves from point Q to R. Therefore, it means that the answer is B, because statement 2 is the only correct statement. And now 1.6 says that light emitted from a distant star contains a spectral line X of frequency f. The spectral lines of this star, when observed on Earth, are red-shifted. Which one of the following combinations of the observed frequency of spectral line X and the motion of the star is correct? So the key thing is that when observed on Earth, these spectral lines are red-shifted. Red-shifted means that the spectral lines are observed at lower frequencies. Okay, so it means here for the observed frequency, it will be smaller than f, and the actual frequency of the spectral lines of this star. And now, if that's the case, based on Doppler effect, it means that the star is moving away from the Earth because you are observing it from the Earth, and while you are on the Earth, it is red-shifted, meaning that it's shifted to lower frequencies. So it must be moving away from the Earth. So the correct answer here is C. Now, 1.7 says a proton and an electron are at a distance r apart. The magnitude of the electrostatic force that they exert on each other is F. Which one of the following graphs shows the relationship between F and r squared as the proton and the electron approach each other? Now, this is obviously a Coulomb's law type of a situation. So you can actually use Coulomb's law to solve this. We know that the electrostatic force between 2 point charges is given by K, Q1, Q2, all divided by R squared. Okay, and now this graph here is supposed to be showing us the relationship between F and R squared, right? And so first thing that we note from Coulomb's law is that these two quantities are inversely proportional to each other. So if we look on graph A here, graph A suggests that as R squared increases, F is also increases, and so this is not the correct answer because these are inversely proportional. Now moving on to B. B also suggests that as you are increasing R squared, F also increases, although it's not in a directly proportional fashion, but this still suggests that R squared is increasing as F increases. And so this is also incorrect. And now graph C suggests that the force decreases as r squared increases, but in an exponential fashion. So it's correct that f decreases as r squared increases. It is not correct that it would be in an exponential fashion. So the correct answer here is actually D. And now some electric circuits. 1.8 says the EMF of a battery is E and its internal resistances are. The battery is connected to 3 resistors and 4 voltmeters as shown below. The resistance of the conducting wires is negligible, while the voltmeters have very high resistances. Okay? And here is that circuit. So let's see the question. The question is, which one of the following equations represents the reading on voltmeter V1 in terms of the readings on the other voltmeters? So the other voltmeters, it's V4, V3, and V2. A says that V1 must be equal to V2 plus V3. And I agree with this equation. This is correct because V1 actually measures the total voltage of the external circuit. And you must also remember that resistors in series are potential difference dividers, whereas voltages in parallel have the same voltage across them, right? So it means that here in this parallel connection, V3 is equal to V4 because these are connected in parallel. So V1, which measures the total voltage of the external circuit, must be equal to V2 plus V3, or V1 must be equal to V2 plus V4. And so that's why this is the correct answer. The rest of the options here do not even make sense. And I think the common mistake that people can make here is taking C as the correct answer, but that is not correct. And now 1.9 says that an AC generator consists of a coil which is rotated in a magnetic field. The EMF time graph for one complete rotation of the coil is shown below. If the speed of rotation of the coil is now doubled, so would you double the speed of rotation? Which one of the following graphs is correct for one complete rotation of the coil? And so this is actually based on Faraday's law. So doubling the speed of rotation will affect two things. First is if you double the speed of rotation, the maximum EMF will also be doubled. In addition to that, it means that the coil will finish one complete rotation in half the time it did here. And so A is incorrect because A suggests that there will be no change. B, we see that in B indeed the EMF has doubled, but the time for complete rotation is still 0.2, which is incorrect. And now if we look at C, indeed the EMF has doubled, and in addition to that, the coil is now going to take half the time it did initially for one complete rotation, which is correct. So C is the correct answer here. D, yes, it's correct that it would now take half the time for one complete rotation, but the EMF must also be doubled, so D is also incorrect. So the correct answer is C. And now the final question here in the multiple choice questions 1.10 says white light is passed through a cold gas and then through a prism as shown below, and a line spectrum is observed on the screen. So the question is, which one of the following correctly describes the energy transition of the atoms of the gas and the type of line spectrum observed on the screen? Okay, so this is a cold gas, so it means that the atoms of that gas, since it is cold, those atoms will absorb some energy from the light. So it means that the atoms of the gas are going to move from lower to higher energy, lower to higher energy. And now the question is, what type of spectrum is observed on the screen? So initially this was white light, right, with all the wavelengths, but now the cold gas will absorb some of the frequencies of light, and then it means that when this light is passed through a prism, there will be some dark gaps for the light that has been absorbed, and so we call that nothing other than a line absorption spectrum. So the answer is D for 1.10. So there you have it. That's my take on these multiple choice questions. I hope you did well on your exams, but at the same time, if things did not go well for you, don't be devastated. Just remember that it's not the end of the world. There is still a chance for you to improve and, correct your mistakes. And so I hope that this was helpful. If there is any other question that you would like me to do on this question paper, you can leave me a comment below. And yeah, like the video and help me to grow this channel by sharing it to anyone who would find it helpful.